Welcome back. So unit 14.5 is our last unit in our last gas law. And that gas law is the ideal gas law. The ideal gas law allows us to do something we haven't really been able to do before. So far we've worked with pressure and volume of a gas, pressure and temperature of a gas, and temperature and pressure of a gas. And given STP, which is standard temperature and pressure, we've also been able to find the number of moles of a gas using Avogadro's law, 22.4 liters per mole. But what if we're not at STP? What if we're not at 0 degrees Celsius and 1 atmosphere? And it's oftentimes silly to think that we always would be. This is where the ideal gas law comes into play. So the ideal gas law is PV is equal to N times R times T, where N is the number of moles we can solve for. So now we can solve for moles even if we're not at STP. The rest of the variables, P is pressure, V is volume. Make sure you convert to liters this time. Whenever you're using the ideal gas law, PIVNERT, you have to convert to liters. So watch out for that. The other gas laws, you could leave them in milliliters, that was fine. But when you're using PIVNERT, you must convert to liters. N is our number of moles. R is the ideal gas constant. We'll talk about that in just a second. And T is temperature, which must be in Kelvin. So this chapter, definitely big to be converting into Kelvin. All right, taking a look at R. There are going to be a lot of different R values. You must make sure that you're paying attention to what unit of pressure you're using. Think about it. We have 3 different units of pressure: atmospheres, kilopascals, and millimeters mercury. So depending upon the unit of pressure that we're using, we have different R values. If you're using atmospheres, 0.0821 is your R value. And again, you'll be given the value, you'll be given the units. All you have to do is match them up. There's our ATM. If you have kilopascals, that number is 8.314. And if you're given millimeters of mercury, that value is 62.363. If you get confused or you think it might be confusing, that our volume must be in liters, just take a look at the unit. They've all got liters in them. So make sure you're converting your volume to liters. Let's try an example. So when the temperature of a rigid hollow sphere containing 685 liters of helium gas is held to 621 Kelvin, the pressure of the gas is 1.89 times 10 to the 3rd kilopascals. How many moles of helium does this sphere hold? So we have a volume, we have a pressure, we have a temperature. We don't have 2 of anything, so we can't use the combined gas law, and we're not looking for a new volume, pressure, or temperature, which is what the combined gas law would give to us. We're looking for how many moles we have. We're not at STP, so we can't use the 22.4 liters per mole. STP would be 373 Kelvin and 101.3 kilopascals. We're not at either of those, so we can't use Avogadro's law. As usual, I like to list out my variables. My volume was 685 liters, my temperature was 621 Kelvin, my pressure was 1.89 times 10 to the 3rd kilopascals. I'm looking for moles, so question mark moles, and then I want to make sure I use the correct R value. I have kilopascals, so I want to make sure I use 8.31 liters kilopascals per mole Kelvin. I want to make sure I use the correct R value. All right, our formula is PIVNERT, PV equals nRT. I'm looking for N, so I want to isolate that variable first. I'm going to do that by dividing both sides by RT. Now I can plug in my variables, make sure you have your appropriate units. Yes, I know writing this big, long, massive unit takes a second, but it's worth a half a point. So here's my big, long unit for the R value. Now I can plug these into my calculator. 1.89 big E3 times 685 divided by 8.31 divided by 621. And I end with 251 moles of helium. All right, now it's your turn. Homework for the weekend.